Morning, everyone. Thank you for joining us on our third day of our Introduction to Deep Energy Retrofits webinar series. It's great to see most of you joining us for all 3 days. And so now we delve into the actual retrofit roadmap. And not sure why, not moving to the next screen. There we go. Thank you. And yes, as I have mentioned in previous days, please stay tuned for tomorrow. That's our 5th module, focusing on some case studies, some deep energy retrofit case studies that have actually taken place within Calgary, and co-presented by Tyler Hermanson of 4 Elements Design and Steve Norris of Steve Norris and Partners Building. So you can see those two are one of our 4 collaborators on this project, alongside Retrofit Canada and True Aim Concepts Limited. And I'll repeat it again, just because there might be some new people. This was a multi-year, multi-milestone, and multi-collaborator project, and which included curriculum training that you guys are attending right now, along with a guidebook, an Introduction to Deep Energy Retrofit guidebook, as well as actual physical deep energy retrofit wall examples that will reside in SAIT, Green Building Technologies wall library, for future reference if you want to stop by. Okay, as we delve into the retrofit roadmap, we're going to explain the importance of an integrated design team. We're going to describe the roles of the various members of that team, determine how to manage a deep energy retrofit and ensure the initial goals are being met. We're going to describe the verification procedures in assessing the building performance, and we're going to examine the processes of the retrofit roadmap. So, approaching a deep energy retrofit, we want to make sure that it is a plan that is the most cost-effective and efficient plan for that house. We're going to start with an energy evaluation and take a careful look at the items that need to be done, and dial in the best version of that, our best 2050 net zero version of that particular house. And that comes back to each individual home is essentially a unicorn. And yes, there are different eras and different construction eras that will apply across different projects. But the reality is every project is and will require its own plan. Also, reality is that deep energy retrofits can be costly. So making sure that a plan is followed so that things aren't done more than once, and examining whether the project can be done within a single stage or a multi-stage approach. Looking at an integrated design process and integrated project delivery. So I'm assuming most of you on the call are well versed in this terminology, but this makes it even more important when you're talking about deep energy retrofits. Ensuring that having educated and experienced professionals from the construction industry that know what deep energy retrofits entail, and including them on the retrofit team, is very important. And also making sure that everyone understands the client's wants and needs. As mentioned, each project is going to be unique, and each client could be unique. And also making sure that there's open communication from design all the way through construction, and making sure that everyone understands the project goals and to achieve the best result. I'm gonna actually skip this slide in light of time. This is just a quick slide that you guys can reference from Passive House Alberta.
An integrated design process, what that means.
So, like I say, in light of time, we have another video later on that we'll watch. We'll just carry on here. The benefits of an integrated design process include lower chance of making costly mistakes or omissions during construction. Ideally, it increases the project efficiency, while also helps decrease communication issues. And then, once again, ideally reduces waste of both time and materials. Integrated building design. So the integrated building design is not just it's not just for planning and personnel. It's very important that the home's materials, components, and systems are designed to be integrated. Like we talked about in the previous session, house as a system ideology is very important and strongly enforced with deep energy retrofits. This is a cutout from our deep energy retrofit guidebook. This is the roadmap that was devised through the project and with the project collaborators. It's broken down into 3 primary phases. We have the assessment phase, the planning phase, and the implementation phase. And we'll go through all of these in the upcoming slides. As you can see, once we have it devised and split, as once you get to the end of the assessment phase as an example, you delve into whether you want to continue the project or not. And after you've gone through a planning phase, the same decision needs to be made. Starting with the assessment phase. This is where we learn about the client and their goals, their wants and the needs, and the reality is, most importantly, the budget. We want to align the client's goals with potential DER practices and the constraints that might come with that. We want to assess the home and site as it currently exists, and gathering that retrofit team who will be working on the project. Getting that team together as early as possible is also important. So as we've kind of highlighted and mentioned before, we've delved into this curriculum training, and we highlight it for the multiple industry professionals out there. So this is written in the way that, we're trying to, this could be applied to a homeowner learning what's involved, but mostly this is for construction professionals. So getting to know the client is important. Understanding what they value and the goals and their goals of the DER project. And do those clients who might just be looking for a renovation understand the benefits and advantages of what a deep energy retrofit can offer? As you can see, there's a number of different things here to look at. In the bottom left corner, you'll notice this one I kind of wanted to touch on as far as is wheelchair accessibility. If we're looking at a number of old existing homes, early 1900s through to whatever, and somebody's made a decision to stay in that home for ideally forevermore, and potentially until they pass, something like a wheelchair accessibility and with the implications that might have to the project, where exterior modifications to an entranceway, whether it be in the front or the back, is something to strongly consider within a project. Learning about the motives behind what the client has decided to do, a deep energy retrofit will help develop the project goals. By first identifying the goals, you can envision whether the desired project outcomes to define what success actually looks like for this project. At this stage, it's very important to understand the constraints that might come with this project, and especially deep energy retrofits. The budget is mostly, well, with any household, renovation project or retrofit project, the budget is key. So what other constraints might be applicable is the actual viability of the project, and we'll talk about that coming up, the potential timelines, and the occupancy. Can the homeowners or tenants actually stay within the home while the project's being done? And then also addressing whether the project can take place within a single stage or a multi-stage. Looking at existing conditions. So ideally, a thorough analysis of the existing building site, of the building itself and the site needs to be done. And it's obviously best if no recent major upgrades or renovations have taken place, so that you're not doing rework like we've talked about before. And this helps to determine the necessary pathway or restrictions for the deep energy retrofit project. And it also analyzes the feasibility of achieving the client's goals. The existing conditions, the primary considerations of these are the following, and we'll go into detail, a little bit more detail on each one of these. So starting with structural conditions. What is a condition of foundation? Are there major structural damages or issues that need to be resolved? What's the above grade envelope and the condition it's in? Are there any structural damages? If so, to what degree? How much work might need to be redone? Is there water damage? That could be something that could be found quite often within a deep energy retrofit type project. If you start peeling back siding and other material and you start noticing water damage, that might have adverse effects on the project goals and the objectives. Can you assess or see what the below grade envelope looks like as well? And whether there's structural conditions or water damage in that area as well. The year built and the materials used. This one is probably of the utmost importance when we talk about deep energy retrofits. And past construction eras, as some of us are aware, obviously used materials that were harmful to humans, especially if they're disturbed, such as asbestos. And have any of the materials been recalled or needed to be replaced, such as poly B, lead pipes, or old wiring, old knob and tube wiring? This is an actual budget, the price tag here from one of our colleagues who's delved into his own deep energy retrofit project down in Southwest Calgary. So his project needed to include upwards of $38,000 in the asbestos remediation on this project. And that was actually the picture you saw two slides back. So testing early will help determine how far a budget might go. Complexity of the building is another key factor. Is it a simple building shape? Luckily, a number of at least within the Calgary area, a lot of the older homes are typically, bungalows that are just rectangle or square, which are generally easy to work with. But as you can see in the pictures to the right here, some of the older type, depending on the era, might have a lot of bump outs, a lot of different shapes, dormers, all those windows within those example homes there would be quite a task to try to retrofit. And then also different building types, bungalows, duplexes, townhouses, multi-units will have different constraints to deal with and consider, especially something like fire safety as an example. Now looking at the complexity of the site. Is it located somewhere that's not planned for redevelopment? That one is also key. If you're delving in and you're putting all this time and effort, especially all the money that goes into a retrofit, is that area or neighborhood not slotted for a redevelopment zone? Does the site have limited access? Is it a narrow city lot? Does it have a zero lot line? Does it have a back alley that allows for materials to be delivered or not? Does it have retaining walls? The side yards and setbacks restrict what you can do for additional insulation on the building envelope. Are there slopes that are of concern? And are there, other underground utilities or overhead power lines, trees? There's a number of things that need to be considered for the site. Are there equipment or materials within the building itself that are near end of life or soon to be end of life and require replacement, such as roofing, siding, windows and doors, mechanical systems? These are easy markers if things are becoming near end of life anyways, and we're kind of talk about that later in future slides, is whether you can include that into the retrofit cost or not, or whether that's just a cost that's going to be incurred no matter what, because the siding needs to be replaced, or the roof does need to be replaced, or windows need to be replaced. Thermal comfort. Are there areas of the home that are drafty or seasonably uncomfortable? What is the condition of the existing insulation? The picture you see on the right here is actually of our colleague's house when he started doing a bit of interior work and found cavities and insulation that had been eaten away by wasp nests. So as an example, when we do our our initial energy audit, it might prove a case to actually carry out some thermal imaging on the house at the same time, especially in some of these older homes that might have lots of different types of issues like this, whether it be wasps, whether it be mice that infiltrate the envelope and start eating away insulation, what have you. So that's something to consider if we're talking about primarily retrofits as being exterior work. An initial energy audit gets done, and we'll talk about that coming up. Thermal imaging might be something to just implement no matter what. And lastly, how old are the windows and doors? Orientation and exposure for potential solar electricity production is something to consider. Is there a roof line that is best suited for solar? South is generally, as we talked about in earlier seminars, obviously south-facing roof line is best. However, east and west also work. Even north. I mean, if, to an extent, it's amazing how far in Calgary's climate, in the middle of summer or at the summer solstice, how far north the sun actually does come up when it's rising. Are there trees or neighboring buildings that are also shading the roof that need to be considered? Sometimes, PV might not need to always be mounted on the roof of the building. Maybe there's other opportunities within the site, depending on how big it is, that potentially mount solar PV on a rack or on a fence or something else, or a shed. So there's different considerations there. Right, as we delve into the retrofit team, it's important to have an integrated design process, which requires assembling the right team. Having a designated deep energy retrofit manager could be something very beneficial to the project. This is a term that might become more and more common as retrofits become mainstay or more popular within the construction industry, the actual DER manager. At the very least, it's strongly encouraged to engage contractors and energy advisors, or anyone for that matter, that has some form of deep energy retrofit experience. So the size and the scope of the project will also determine how big that team needs to be. As we kind of delve into what each team member might actually do. So once again, engaging an experienced energy advisor or auditor is strongly encouraged. They perform an initial energy audit and know where you're starting from as far as an energy use within that home. And then they should ideally perform the final energy audit. Ideally, it would be best to have the same auditor do both. They can also advise on the best bang for your buck for some changes. Once again, that comes with an experienced energy advisor. General contractor or builder, ideally you're involving or engaging one that has some experience and knows the topic. They can have a lot of input on the constructability of the deep energy retrofit and its approach. And ideally they'd have knowledge on materials, pricing, availabilities, and scheduling. Building science consultants. We talked about that in the topic yesterday of building science. This, depending on the knowledge of both either say you have your builder or your contractor and or your energy advisor, you might require a building science consultant, especially if you run into some issues that you found when you've done the site assessment or the building assessment for that matter, or you're trying to apply a new approach and adding X amount of insulation and all those building science considerations we talked about yesterday, and where in that wall assembly the dew point might land and what have you. So also architects, engineers, designers, those are applied as needed if there's specific engineering needs and structural requirements or changes that might need to be made. Once again, engaging ones that might have some experience is also key. Subcontractors, trades, ideally they have some experience, but making sure that they're on board early so that they know what the intent and the goals of the project are is very helpful to the project. The building owner and occupants, making sure that they have input and know what the energy use is, what maybe the amount of tenants if it's a rental, making sure they understand the changes in the systems that are going to be used and how they'll affect the house and the building performance. Then also looking at the authorities having jurisdiction, they have the input on the applicable codes, making sure that they're involved early as well if needed. And utility providers, especially as Ben talked about in our previous seminar on doing a utility well, if you need to do a utility upgrade, making sure that they're involved early, especially with the costs that might be incurred on that. Next is the planning phase. So this begins, ideally, every project should start with an initial energy audit to know the starting point and to help inform the plan to get to net zero. Then you can start looking at the DER approach, whether it's a single stage or a multi-stage, And from our experience, that would primarily come down to the budget. And, if whether the homeowner or the building owner needs to seek additional funding. Then you start doing some initial designs and some cost estimates. And this process can help determine whether certain things need to be compromised on, some changes need to be removed, or some things need to be removed or changed, and it can help also inform the DER approach. So the initial energy audit will help quantify the home's existing performance. It can also inform the net zero plan for that home, the ideal version of that 2050 home, and help determine where to focus and what might be able to provide a better bang for your buck. Looking at the EnerGuide label in a bit more detail. So if you have an existing audit done, that large number in the middle shows the existing rating and the gigajoules usage of that home. The number below that is the typical house benchmark that would be built to code at that time. So if you did an audit on a 1950s home and it's a really high energy use, like 170 gigajoules, if that same house was built today at current standards, you'd have that lower number as a benchmark. On the right in the middle, you see where the energy use according to the model is being distributed. Like we talked about and highlighted previous days, space heating is the highest in our current climate, in our climate anyway. Followed by, as you can see in this one, water heating as well, then lights and appliances and other electrical uses. You can see where your impact on the environment is on the bottom right for that current home. And on the left, you can see where the distribution of the energy is being consumed. Generally, this one as an example has oil in it. So I think as an example from Eastern Canada, generally within Alberta, we're just looking on as electricity and natural gas consumed in that area there. And ideally, the goal is to get to net zero or to 0 gigajoules. Air tightness testing being done with the initial energy audit is also key. This tests how many times the volume of air is changed within the house within an hour at 50 pascals of pressure difference. This helps quantify the amount of air leakage through the airtight layer. So the lower the ACH 50 value, the better. And using a smoke pen can help locate. You can see the picture in the middle there on the left. Using a smoke pen, once the home is pressurized, you can go around with a smoke pen and determine, try to find air leakage points. You can see the top right is a thermal imaging camera that can be applied within the audit. And that you can see where there is cold spots versus hot spots in the temperature difference there and the wisps of air that are coming in or that are being leaking. An example there, one air change means that the entire volume of air, 100% volume of that air is changed within an hour. As an example, the lower the ACH value, as an example, 0.6 means that only 60% of that air volume is changed. What target should we aim for? Well, ideally, the goal is to get to net zero. And easier to achieve this by, like we talked about in previous days, focusing on the envelope first, making sure that construction is done to an airtight standard, using high insulation values, good quality windows and doors, and making sure, like I said, that it is good quality control to ensure that the project is done to a good airtightness standard. Now, when we talk about the deep energy retrofit approach, we kind of focused on whether there could be a single stage where everything's done in essentially one project. This sometimes has a larger upfront investment, but potentially more affordable in the long run compared to a multi-stage, which follows a detailed plan, but is done in planned and executed stages. And like I mentioned before, a multi-stage approach would probably be the more used approach because it really does come down to the budget and whether the homeowner has the available funds to do this. Key is to focus on not completing piecemeal retrofits. Now that term, I believe, may have been coined by Peter Amarongan of Retrofit Canada. And the main reasons to avoid these is so that we're not redoing work. And, you know, that if a existing plan isn't in place and people are, you know, the issue or the reality is people might have, you know, greener ambitions, wanting to reduce their energy consumption, want to make improvements in their home, and kind of just start tackling a few things here and there, but with no overarching plan. This can lead to higher costs, more overall work in the end, potential building science concerns if they've, you know, started doing something and then haven't fully thought it out. Like we talked about, where, you know, where the dew point might land within the wall assembly now that you've added extra insulation. Might lead to extra mistakes and errors if you have different trades come in that isn't part of that holistic plan. So a well thought out and planned approach, whether it be a single stage or multi-stage DR, is the best avenue for success. So starting with an initial design. So all the information that was gathered already is actually put to paper and start further considerations. So one of the main things to consider is the durability. Will the proposed deep energy retrofit project hold up over time from multiple scenarios, from the building science perspective, from a material usage, from the water management perspective? And then the considerations that have a significant effect on the final outcome are structural changes and requirements. Are there anything that needs to be changed within the building itself? What are the heating and ventilation requirements? What types of insulations are going to be used and where? We talked about quickly yesterday the window placement and window types, whether the flange or flangeless. Are there trees and landscaping to consider, like we talked about? Overhangs and shading, and once again, feasibility for solar production to get to that net zero goal. Other considerations within the deep energy retrofit initial design is how will water be managed, bulk water for that matter, and guided away from the house. Are the assemblies that are thought about in the initial design, do they have drying potential? We talked about yesterday and showcased smart vapor barriers that allow drying multiple directions. Ensuring that the airtight layer is continuous and detailed at all connection points, all penetrations. Making sure the vapor barrier is located in the right spot within the envelope. Are we meeting all the local codes? Have we considered the fire safety implications? And talked about before, setbacks. When we talk about a deep energy retrofit, we're adding potentially 8 inches or even potentially more, who knows, to the envelope. Are we running into setback and lot line considerations and issues? Are the materials easily sourced? Are they within budget? Are they straightforward to install by other people or other trades or other contractors on the project? And are the trades themselves, are they knowledgeable enough and willing to do the work? Then you get into doing some cost estimates. So the initial plans and start getting out some rough cost estimates that, comparing it back to the initial budget that was talked about. So this can be an iterative kind of multi-step process. You come up with an initial plan, you get some initial pricing. Do the plans need to be adjusted based on the costs? Then potentially new pricing. And then it's a continual process until things are agreed upon. We highlight this here. So this is a bit of an older quote, but it still applies nonetheless. So if Les and Walker found, on average, deep energy retrofits in the United States were cash flow neutral on a monthly basis. However, variability was large, with some projects substantially reducing net monthly costs and others substantially increasing net costs. Therefore, drew into question the cost effectiveness for deep energy retrofits and potentially being a barrier to widespread implementation. So this one, we kind of talked about, it's important to not just focus on utility savings. I mean, that's a key. Obviously, that's, if you're going to do all this time and effort and put all this money towards increasing the building envelope performance, and then improving the mechanical system, and potentially disconnecting from natural gas, and you have solar PV, and geez, you might have very severely reduced utility costs, but the payback on that, multi-$100 per month savings versus over $100,000 retrofit budget. We can't just focus on the monthly utility savings. It really also comes down to, is it a replacement cost or a retrofit cost? If your siding needs to be done anyways, it's old, the roof is failing, or the shingles are old and need to be replaced. Well, these are, existing replacement costs and shouldn't maybe be included in a retrofit cost. It's, as an example, the extra insulation is that added cost. And the reality is deep energy retrofit savings can be recovered through annual energy savings, but, like I mentioned, it's not the only consideration. Really also need to focus on the added comfort from the homeowner, the health benefits, the environmental benefits, and ideally the durability. So we talk about funding a potential project. There are incentive programs out there that focus on deep energy retrofits, and the reality is this is progressing quickly. Within the research world and grants that we work with, retrofits is a topic that is not going away, and there'll be potentially more and more incentives, whether it be a municipal, provincial, or federal, that are put towards deep energy retrofit type projects. So most programs do require working with professionals, whether they be an energy advisor or potentially a net zero builder, to qualify for those upgrades. Making it, some professionals who have the DER experience are knowledgeable on the incentives available and can help even apply and receive them if you've engaged with them in the project. It must be noted that some programs require a larger lead time, and if the project's already started and then you start applying for incentive programs, well, you might not be applicable anymore at that point in time. So it's lots of things to consider right at the beginning of a project. So some examples that are out there are the Greener Homes grant, and there's been discussions, if I'm being perfectly honest, with the Greener Homes grant, which is up to $5,000 to do some home improvements. Now, unfortunately, that one, through some project discussions, has led to a bit of a piecemeal approach. So, they offer money to improve your mechanical system, new furnace or heat pump or potentially solar PV, and no other improvements or windows. But if there's no major plan or no proper plan behind that, that can unfortunately lead to a bit of a piecemeal approach. But the Greener Homes loan is up to $40,000 as an example, and a 10-year payback. The Calgary Clean Energy Improvement Program is another example, and other municipalities have them. I know Edmonton and other ones within Alberta. This one is potentially up to 100% of the costs provided up front with long payback periods. But it's also, in that instance, it's attached to the property tax of that property, of that building. So it's not tied to the homeowner themselves. So if they decide to move within 5 years, that cost rests with that home. And so it's not attached to the person. So now into the implementation phase. This is the third and final phase as we've described, and we start finalizing the design and the contract for construction. We acquire the necessary permits and all the necessary documentation so that construction can get started. Making sure we follow the scope, making sure that follow that plan for that home. And once again, backing up and confirming the project goals, the final energy audit, and making sure that the project can be handed over to a happy client. So this is where the initial design and costing gets signed off and gets focused on a final design and contract. This is where engineered or architectural drawings might need to be sought after. looking at the real property reports or plot plans, installation details, all specifications, looking at the electrical upgrades and the plans behind those and what might need to be done within the project, and finalizing the working drawings. It was noted that deep energy retrofits will probably follow a cost plus contract style because of the unknowns encountered within retrofits. This is where we start establishing the construction schedule and the timeline. We start ordering materials, looking at the lead times on certain things. Ideally, we're coming out of a supply chain, the issues from COVID, a supply chain. Ideally, things are getting better nowadays, but there are certain things that have long lead times that can affect the construction schedule. Acquiring the permits. Does a municipality have specific or special requirements that they require? Following all the safety measures, putting in public protection on the site, following all OH&S requirements, looking at the scheduling. Like I said, long lead times on certain materials or components or equipment. Whether it be work stoppages or delays because of weather, or if it's a certain time of the year, if you started the project right at the start of winter and all of a sudden we hit a -20 cold snap that lasts for weeks on end, or you've started in the spring when it's raining nonstop. So things to consider. Making sure the site is prepped accordingly as well. What needs to be protected? Are there trees on site that need to be protected? Are there, city property that needs to be protected? Does the house need to be completely, can there be certain areas of the house that need to be entirely separated to accommodate the tenants, or while the work is done, or do the tenants need to leave the house or the building while work is done? All things to consider. Once again, important, make sure the client or the tenant understands the construction process and how they will be impacted. This will go a long way in making sure that client, avoid frustrating clients and misunderstandings. All right, construction or deconstruction of the project can begin. If doing a demolition, confirm how much needs to be demolished. How far will it go? I don't want to start demolishing more than what is required. And once again, talked about possibility of running into unknowns. Once you start peeling back existing materials, do you end up finding that there's structural damages, or that there's wood that's been rotten out or eaten away, or whatever the case may be. So demolition and or when you start deconstructing, this is also another big factor on a potential budget. So once again, back to that cost plus, where any project, any deep energy retrofit project is unique and will potentially encounter its own issues along the way. So need to figure out whether the existing building is going to be completely torn down or just partially, as you saw in that past example here. And I'll go back. This is, quite a bit of the project was actually taken away and deconstructed. Is deconstruction feasible? Is it worth the cost? Is there room on site to actually store some of the materials that you start deconstructing? So looking at deconstruction as part of these, I believe some of the question about material use or landfill waste and what have you was discussed yesterday. So that's something that needs to be looked at with these deep energy retrofit projects. How much of the material can be salvaged? How much can be reused? How much can be potentially sold? How much can be repurposed somewhere else, recycled? And then, unfortunately, eventual disposal. Also knowing which companies and or businesses in the area or within the surrounding area, for that matter, can handle the materials or be part of the process of deconstructing materials. This is an example of a project we took on, and we devised this type of inventory list for a deconstruction project. looking at different parts of the of the home, and coming up with some categories, and or what a primary designation could be or a secondary designation. So these are things that could be potentially applied or could be thought of for any deep energy retrofit project, especially one that's wanting to try to salvage some materials. And what's the possibility of actually rebuilding with some materials that came off the site? There could be there could be ample opportunity to reuse some of the materials that's been taken apart. Old studs, for an example, could be taken down and ripped to be potentially used for strapping for exterior insulation, or for rain screen applications. Old joists, old floor joists can be used for modified Larson truss, as an example. So these are kind of things that, as this retrofit industry matures and evolves, these types of things will become more and more applicable, trying to reuse and resalvage materials and repurpose them. So I think with that, I'm going to hand it over to my colleague, Ben. But I think, why don't we take a 2-minute break or a couple-minute break, and before that, we'll answer a couple of questions that are here. We'll take a couple-minute break and then we'll return, and Ben will carry us out to the end of the session today.
Awesome. So we got a couple of questions. And one thing I want to note really quickly on that deconstruction piece to keep in mind is that a large majority of the retrofits that people are going to be involved with aren't going to include extensive demolition. They might just be removing that cladding, removing windows and doors, and replacing them. But where we are doing larger demolition as part of a retrofit to, at the same time, maybe change some of the uses within a home to make them better suit the occupants, we need to keep in mind that deconstruction option to preserve materials and have them be repurposed. So a couple of questions here from Steve. He's asking about air changes per hour and what's code generally, and what is considered a good ACH for DER. So in the upcoming the 2020 National Building Code, the base requirements for air changes per hour for the lowest tier are 2.5 ACH 50. And as you get up to higher tiers, there'll be higher air tightness requirements to get that higher performance level out of buildings as well. So 2.5 ACH is the base code requirement. And I believe that's similar to current codes before 2020 is being adopted within Alberta and other provinces. A good ACH for a high performance net zero new build or deep energy retrofit, I would say a good target is 1 to 1.5 ACH. I believe for the Canadian Home Builders Association, if you're looking for their net zero reno certification through CHB, I believe the requirement is an ACH of 2.
Under
two or less. So, and what we found in a couple of case studies that we'll be going through tomorrow with Steve and Tyler, that can be difficult to hit in some of these retrofits. And it all also goes to what are the exact conditions and what are you disturbing as part of the retrofit, which we'll get into tomorrow a bit more with their specific retrofits and what they were tackling there. So Karen is asking, do you think a multi-stage retrofit helps to better determine if the net zero model is working for the building, as it gives time to monitor the building performance during the interim and make potential major adjustments that were not anticipated to the other phases? I think that is a possibility.
That's an interesting point.
Yeah, I think part of the thing with having a good retrofit team and a good experienced energy advisor is that they can develop a really good model on how, as Peter Amarangam puts it, what's the ideal 2050 version of this home in a net zero performance metric. So what does that look like? What are the different aspects of that? But that being said, with that model and that picture and also an EnerGuide rating, those are just models and they aren't the actual occupant behaviors of those. There's a lot of rules of thumb that are just used because we don't know how long everyone's going to be showering for. I like my guilty pleasure from energy efficiency standpoint is a long hot shower. So we don't know how the occupants are gonna be living in a home like that. So as you do stages, I think it is important because you can to just take into account how things are working and can that inform the next stage. But we already have that general plan that's been established, so we can do minor tweaks to that, to how can it be optimized. If we replace the windows and do the insulation, we haven't done the mechanical system yet. We can see how the existing mechanical system's impacted, and maybe that might cause us to pivot and how in the end we want to address the mechanical system after we've also addressed the attic, for example. So
yeah.
when we're doing in a retrofit in stages, it is important to take whatever information you can to inform the following portions of the retrofit.
You bet.
So yeah, so with that, I guess we can take probably about a 3-minute break, and then we'll dive into the next section here.
Okay, thank you all.
All right, so we're gonna get going here. This next section in the retrofit roadmap, we're gonna get into different retrofit options. Just 1 second, got a bit of feedback here. And should be good. Hang on one second. Technical difficulties. Yeah, just unmute yours.
Okay, so we're gonna look at some common systems that are used for retrofitting. First one we're gonna get into is the Larson Truss, which the history of this actually just comes out of the Edmonton area in the 80s, I believe. So this is a system that's used to basically add an insulation cavity outboard of the wall. So you would strip the siding off, expose the existing sheathing, complete any repairs due to moisture damage that's needed. And then you would frame out with 2x2s to create this cavity and with plywood gussets. An advantage of the Larson Truss is you can make it to any depth that you need to based on your desired insulation performance. And most commonly, the cavity is filled with a dense packed cellulose insulation, but you can also get blown in fiberglass or blown in mineral fiber insulation as well. And there's also some blown in wood fiber products coming to the market as well for more environmental options on there. So in this image here, we're looking at kind of the different stages of the Larson Truss. So you attach the 2x2 directly to first 2x2 directly to the wall. That's what's done in this instance. And we'll be getting into this specific retrofit a bit more tomorrow with Steve Norris. Then you can see as they attach the plywood gussets to the wall in the center image here, they actually utilize that to straighten the wall. So an advantage of doing a Larson Truss in pieces like this is you can straighten a crooked wall that might be crooked top to bottom or even down the length of the wall and get it nice plumb and true. That's one of the things we do run into with an older existing house, and on occasion is the lines aren't quite even or they're out of plumb. So where we're just adding a board insulation to the outside, we're basically stuck with that existing profile within the home. So Larson Truss gives us the option to straighten that. Also with panelized retrofit methods, we can straighten that as well. You can see here in the image on the left, they added window boxes, outboard tying into the existing window detailing. Most of the windows on this project were replaced, but there are a couple that they left that weren't too old. And then after you have that cavity created, there's a special netting that's installed across the face to retain the cellulose insulation. And then once that's installed, you can see in our wall library sample on the right, you can see a blue membrane on the side. There's a heavier duty weather barrier membrane that's installed on the outside. So on this retrofit here, they ended up using Typar for the exterior weather barrier. So there's not another sheathing that goes outboard of the insulation cavity, just a good weather and air barrier that's put on. So that's the Larson Truss in 2 or 3 minutes and how that goes. And here's another image, and this is what's referred to as a chainsaw retrofit. This is a project done by Corey McDermott south of Calgary. Chainsaw retrofit is where they're basically they can use a chainsaw, thus the term, but you just cut off the overhangs of the roof and then you just create a cavity, basically a Larson Truss cavity all around the home. So another option for retrofits, which was done in Tyler Hermanson's retrofit we'll be talking about tomorrow, is looking at installing an exterior board insulation. So we can look at a mineral fiber board insulation, a semi-rigid, such as in the image here, or you can look at a expanded or extruded polystyrene insulation as well. Tyler Hermanson's project used the new low GWP XPS insulation. One of the key constraints with adding exterior insulation like this is that sometimes with the fastening of strapping and to support the cladding, you might need engineering for that. Some of the insulation manufacturers, such as Rockwool, they do have charts and tables that can help guide what the fastening is required. And if you base the fastening on those requirements that they've published, that can be submitted to the municipality and in many cases can be good for dictating what you're doing for your fastening and make city officials happy that it's being done properly. A couple key concerns with doing an exterior board insulation is how do you guarantee you're hitting the framing or the structure behind when you're fastening those long screws through. So it takes some thought by the workers on site, but it is being done and is being done quite well in many occasions. The other concern is if you're using a weather barrier airtight layer on the exterior sheathing that your insulation's outboard of. If you're fastening through and you miss a stud, then you need to leave that screw in place. If you pull it out, then that creates a hole in the air barrier. So a couple constraints to this one to keep in mind to ensure it's a good durable system. One advantage to this though is if you have the Rockwool insulation that you're using, it's a good fireproof or fire resistant option for the assembly. And there's a couple images from Tyler's retrofit here. So they had an inch and a half of pre-existing XPS insulation on much of the house that was added, I believe, in 2000. Previously, there was no insulation in this house prior to that. So they added an additional 4 inches through the retrofit on the exterior. And then you see the strapping that's added below, and the vent in the image on the right kind of shows some of the detailing constraints that we have to look at when we're adding exterior insulation, and how are we sealing and maintaining airtightness between different transitions and junctions. And here from our wall library, just illustrating a couple options. We can have just 4 inches of a foam insulation. Here we have the graphite polystyrene insulation on the left, and then another image of the mineral fiber insulation on the right. Another option for cladding, we'll have a video which goes into a bit more on this for cladding and exterior insulation all in one, is an exterior insulated finish system or EIFS. This is very common in commercial construction use, and it provides a great system with a liquid applied air and moisture barrier, uses an adhesive to attach insulation boards, which is 99% of the time an EPS insulation. You can also do, there are a couple manufacturers that do a mineral fiber insulation, and I believe you can also get XPS insulation as well. Then you have a reinforcing mesh and then a base and finish coat. You basically end up with a 1/4 inch or so of a stucco finish outboard of the insulation. Like standard stucco systems, if these are done right, these can be a very good and long durable finish system that has insulation as an integral part of it. And you can go up to commonly 12 inches of insulation you can add with this method of insulation. The one drawback to EIFS insulation systems is the susceptibility to woodpecker damage, because woodpeckers like the hollow sound they get from knocking on it. So not every single project, but it's not super rare for people to have issues with woodpeckers running holes through the insulation, through the EIFS in some locations, which will require patching. So that's one thing to keep in mind with that system. And now we're going to have this video from going through EIFS installation on one of the projects.
We're here today in lovely central Alberta at a Solar Home Inc.'s project, where we're going to see how they use high performance construction and passive house techniques on this deep energy retrofit of an existing home. So here's a great location where we can see a number of different wall assemblies that are being done on this deep energy retrofit. This is an on-site deep energy retrofit. So the first thing they do is they take off all of the old siding, strip it back down to the original sheathing. And that way you can see if there's any rot or mold or any degradation of the sheeting and repair it so that you're starting with strong structure as you build out. So I'm here with Peter Darlington, owner of Solar Homes. And Peter, why don't you tell me a little about the wall assemblies that you're using on this deep energy retrofit?
On this project, we're using EIFS, which is exterior insulated finish system. The brand is a Stowe, and it's the classic therm system that we're using. The nice thing about this assembly is that Stowe manufactures all the products from the sheathing out. And they have a full CCMC package for when you're doing your building permit submittals. And it's a really nice system and easy to use. So here we're using Stowe's classic therm system, which incorporates a liquid applied air barrier, which is called Gold Coat. It's a two-step system. The first step is to use gold fill on all the seams of the sheathing. And then the second step is to run the gold coat over the entire field and covering the gold fill as well. And you can see a bunch of different steps on this. We just replaced this door yesterday, and there was some rot underneath this door that we had to replace the sheathing. So we've got a bunch of varying steps. You can see some peel and stick that goes into the rough opening for waterproofing the rough opening. Door was installed, spray foam, and then we have another layer of peel and stick to come and just close off this gap between the door and the RO. Down at the foundation, we've excavated 18 inches below grade and put a 4-inch layer of XPS that's been mechanically fastened. And then we have a drainage flashing here so that any water that gets behind the styrofoam will drain down this wall and is able to evacuate out the bottom of the wall assembly. You see we've got some penetrations in varying states of completion. One here that's completely untouched. We've got another one up at the top that has a peel and stick membrane being used, and then it will get a coating of Rapid Guard at the cuts. And this Rapid Guard is specifically for transitioning between various materials. So we use it on the transition from concrete to lumber, as well as to close up the top of the peel and stick, which when you're sticking it to concrete, always has little gaps in it. So we use that liquid applied membrane to close up the top of that peel and stick. So with the Stowe Classic Therm assembly, there's a liquid applied air barrier that goes direct to sheathing. And then we have a EPS, which is glued on with a notch trowel, which creates a drainage cavity between the EPS and the liquid applied air barrier. So any moisture that gets inside this wall has a channel to drain down the wall and out the flashing at the bottom of the wall.
All right. So that's the EIFS system. And sorry, Dean.
Yep. So I just wanted to confirm whether you guys could actually, I'm not sure if somebody could put something in the chat. Just curious from your standpoint, whether that functioned properly, whether it was lagging, or whether you could hear everything properly. If somebody could just put something in the chat, this is just for our knowledge for future, because it did seem like it was having an issue. A bit laggy. Okay. All right. Good to know. Thank you, Steve-O.
All right. So moving on from EIFS, the next option we have, which is something that's being tested across Canada in several locations and comes out of, there's a lot of work in Europe and the Netherlands with Energy Sprong initiative, was looking at panelized retrofits. So this is a method of prefabricating wall sections and installing windows, getting them largely weather tight off-site. And then when you get onto the retrofit site, you can just lift them into place. So you don't necessarily in many cases need to even remove siding or existing windows until you pop these panels in. You just pop the windows out the same day that the new panels coming in and do a tie-in with the jambs. So it's great system when we're looking at ways to optimize. Early research is kind of showing this in many cases, or potentially in most cases so far, is not currently in its current state in Canada, not the most cost-effective option, but it is something to look at. And there is research happening up in Edmonton and in Ottawa through NRCan, and how can we further optimize these systems. I'll talk a bit about it here, and if you are interested in more on panelized retrofits, NRCan earlier this year released a peer guide, or panelized energy efficiency retrofit guide. So you can look that up for more information and recommendations based on their research and consultation with experts for panelized retrofits in Canada. The stages of completing panelized retrofit is basically starting with digitally capturing the dimension of the home and getting that into design software to size up the panels. Early work used LiDAR scanning, which creates a point cloud. We kind of found that's a bit complicated to get clean lines off of to dimension panels from. So now they've moved to photogrammetry, which basically takes imaging from the home with a drone, or even just stand on the ground with a camera for walls. And just by measuring a couple points on each wall on site, you can translate that into the images on computer with software, get all the dimensions that you need to base panels off of. Quite often, what these systems are doing, they will have the framed wall section with the window installed and weather barrier. In some cases, they're adding insulation as well off-site, and then you're installing them, just lift them in place on the house and sealing the joints between the panels. There's brackets that are installed on the home to support these panels for loading on the base and then attaching the top to hold them in. And they're designed with a bit of leeway, like an inch or so of leeway between the panels to optimize the installation and to make sure everything lines up quite well. Then gaps between panels are also filled with insulation. So here we get into some of the images from project up in Edmonton, the Sandercock Harzma home in Edmonton, and there's a full case study of this available on Retrofit Canada's website. That's retrofitcanada.com. So here we can see in the image that they basically installed a preserved wood box beam to the foundation wall to support the main level wall panels. And then I stop having mouse issues here. And here we have a panel drawing. One of the things I looked at doing on this house and also in the Sundance Housing Co-op as well is that they basically had a sheeted 2x4 wall with weather barrier on it, and they lifted the panels in place. And I think if we go to the last slide, you can actually see the gap between the panel that's created. So you have the 2x4 wall section. And then once the panel is installed in place, they're able to fill that 8-inch cavity that's created with a dense pack cellulose insulation. One of the reasons they did the insulation install on site was to simplify the craning of the walls and transport by keeping them significantly lighter. So dense pack cellulose is typically installed in a density of about 3 pounds per cubic feet. So adding 8 inches of that to these walls would be significant. It's also allowed for using that existing wall of the home as the backside of the cavity for holding the insulation, and thus simplifying the panels that were created. As we get here, here's a couple of images of them craning the pre-existing house, craning the panels in place. And with the walls being lighter, they were able to use a more nimble and smaller crane to get a majority of the panels in place. Whereas when we increase the weight of the walls, then we have to increase the capacity of whatever crane we're using to put it in place. Some pre-insulated panels might require larger cranes that could come at fees of hundreds of dollars an hour to use. So another thing to keep in mind with budgeting for different options. So we can see here in this photo, here's the house pretty much weather tight and just waiting for cladding. Final option to look at, which is not done super often, is adding insulation on the interior of the wall. This is an option if you don't have the ability to add insulation on the outside due to site constraints, or if you have if you're already gutting the inside due to other improvements that are needed with wiring or plumbing or etc., you can add insulation to the wall as well. So one thing to keep in mind is if you have a wall system that existing, there's potential moisture issues in it. In many cases, that moisture issues can better be resolved through insulation on the outside as well. Another concern to look at with adding interior insulation is you're cutting into that living space within the home. And from my personal experience, attaching drywall through a foam insulation into studs with longer screws is a bit of a pain. So I prefer the drywall directly to the studs. So interior insulation is an option to keep in mind though, in doing a retrofit. And you can also use that as, especially with a foam board insulation or one such as in the image that's foil faced, you can tape the seams and that can be your air and vapor barrier as well as part of the retrofit. So another option on the interior, if you're getting quite invasive, is you can add another stud wall to the interior and drywall it, and that can be a cavity for dense pack cellulose or other blown in insulation as well. And you can just space that inner stud wall to whatever depth you desire for insulation performance. One of the key things to look at, regardless of the type of insulation system you're using or the type of work you're doing, is that detailing is extremely important. It's how we maintain that continuity of the control layers we talked about yesterday. And the images we see here, we see ceiling wire penetrations. One general rule of thumb is 1 wire per hole. That allows for easy and simple air sealing around wires. If you have a bundle of even just 2 or 3 wires, it complicates things in having a good air seal around the wires. And if you have even more than that, it makes it more complicated. You can see the image on the left. This is a top plate of a wall looking down from an attic. You can see the ceiling of the ceiling poly on either side of that wood stud, and also where there's wires coming up through the top of the wall, those would need to be sealed as well. And these are areas that are not typically sealed in standard construction, especially in these older homes that we're retrofitting. But it's important to look at any transitions, any complicated conditions, making sure we get the detailing right on these homes to ensure that it's going to perform well. One method we can do to do this in the design stage or planning stage is to take a section of the house, such as in the image here, and just complete a red line test. So draw on that with typically a red marker, that's the red line term. Trace where your air barrier is, for example. And anytime there's a change in direction, or if you have to pick up your pen because there's not something accommodating the air barrier at a certain location, that's where you need to make sure you're addressing with the proper detail to make sure things are done right and going to perform well. And you have those continuous control layers. So that red line test can be done with all the control layers, but the water control and the air control layer are the most vital ones to complete the red line test for. So the other thing to look at too is with detailing is all the different variables that might impact it, such as the design. One of the things we look at with retrofits, ideally we talk about envelope first and adding as much insulation as possible, but sometimes we are limited in the practicality of detailing a large dimension of insulation added onto the exterior of the building. So it's something to keep in mind when we're planning these retrofits. Other variables that can affect detailing completed on site is the accessibility to the site, the weather when you're doing the work, and different site conditions and issues, and most importantly with completing good detailing on a retrofit is the worker skill and knowledge. So it's important to take time and do mock-ups, and that feeds into the next bit here we're going to get to in verifying and quality control of the retrofits. So we can't just design these projects and then set the contractor to work and have the workers go to town and do all the things that they want to do to fulfill that retrofit without any verification to make sure things are done right. We need to have a quality control plan and checking different stages, doing mock-ups of each condition, such as a window install, ensuring that the first one is done right that meets everyone's expectations, and all the subsequent ones are done in a similar way. This is a practice and standard new construction on larger projects, and it's a key way to ensure that a deep energy retrofit is done properly through doing a mock-up of each condition and making sure it's done the similar way throughout. But through quality control and regular inspections, we can ensure that we're getting that quality we need out of the retrofit, and it's going to perform as designed. One thing to keep in mind is that any inspections by a code inspector from the municipality, they're not focused entirely on the quality of envelope work or the quality of different aspects. They're focused primarily on life and fire safety and compliance with bylaws as per any submitted permit drawings. And the key thing to look at with quality control is that all the key building science principles are being followed, and there are going to be changes as we go through the work. As you get into it, you start tearing things apart, start doing the work. There's going to need to be some adaptation or some revisions to detailing as you go, but it's having open communication and being on top of things to make sure that they're properly addressed. One key thing to look at in these retrofits to maintain airtightness, one thing we can do is have an air boss on site, or one person that's responsible for ensuring air sealing is done right. We're talking to different trades such as electricians or the HVAC installers or plumbers. It's getting them understanding that anytime they're poking what the air barrier is, what that air control area is, and anytime they're poking a hole through that, making sure that's addressed by themselves, or getting the air boss or designated person on site to ensure that that sealing is completed, so we can maintain a high quality air barrier in the assembly in the building. So finally, the last stage, which isn't thought of much residentially, but it's commissioning. That's making sure that all the systems in the house are working as designed from a mechanical standpoint, and it also helps us ensure that we're achieving the proper energy savings, because if the heat pump isn't properly commissioned or the HRV or ERV isn't properly balanced, it's not going to work as well. It could lead to health issues and lower efficiencies and thus higher energy use than is planned. But when we have properly commissioned systems, and that also extends to the building envelope as well, we can make sure that the building envelope is airtight through that final EnerGuide audit, that final blower door test to verify it is performing properly. We can also look at, as well, from the envelope commissioning standpoint, we can look at doing water tightness testing at window detailing as well, especially if there are some concerns on some windows of how effective due to certain constraints that detailing was. We can verify it through site water test. Other systems we might want to look at commissioning as well as the electrical system, especially if there are significant changes to the electrical panel. We want to make sure it's working well, or you've installed load control or load sharing devices or smart electric panel, making sure that functions well before things are handed off to the homeowner. Are there other control systems or different water distribution systems that were updated as part of the retrofit? Just making sure all of these systems are working as planned and intended before things are passed off to the homeowner, so we could minimize callbacks and, most importantly, have a happy client at the end of the day. So another thing to look at with commissioning, which I referenced earlier, is that air balancing, whether it's the HRV, ERV, or air handler system for a heat pump, is ensuring we're getting the right airflow to every room in the home, and that ensures we get the optimal performance of the system, and it also ensures optimal comfort. Through an F280 heat load calculation, we can determine how much heat is required in each room. And through the sizing of the heat pump system and the temperature of air flowing through that, we can see how many liters per second of air needs to be provided to that room to provide that heat or that cooling in the summertime. And we can balance that system to tune in and get that exact amount. A large amount of homes right now that have cold rooms or hot rooms at different times of the year compared to other rooms in the house are due to an improperly balanced heating and ventilation system. So part of the commissioning needs to accommodate that, especially as we are touting these retrofits as being super high performance, super high efficiency, and comfortable as well. Having a properly balanced heating and ventilation system is a key aspect to achieving that comfort in a home. And then finally, as mentioned earlier, kind of the last step after everything's commissioned, right before you're turning the keys back over to the homeowner if they were staying somewhere else during the process, or I guess returning your key and not coming in when you're done working on the house as well. Right at that very last stage is when you get the final energy audit done and you verify final air tightness numbers. And part of that will be verifying work that was actually done compared to initially planned for the house, so they can run the final energy performance numbers for the home. And then we get the post retrofit assessment, your final EnerGuide rating, and ideally you're going to get a big fat 0. This is the one time we're getting a 0 on a test is a good thing. So this is once you've installed solar, you can to accommodate your energy use annually, then you can, as you can see on the image on the right, that cancels out your energy use, leading to a 0 gigajoule a year as modeled energy performance for the building. So this is the goal. This is what we want to look at. So we covered a lot today. See, we've got a few questions here. Finally, once we get that energy audit done, we have the client handoff. And part of that, which I almost missed at the end here, but is educating the homeowner or occupant, making sure they understand the different and the new systems in the house and how they work. There's a lot of different things that we go into. There's a lot of points on this slide here, but what's required in the day-to-day operation, what's required for maintenance. Other key things are providing the different operations manuals and maintenance manuals for the components that were installed. And most importantly for homeowners and to ensure that they're happy, and they'll give good recommendation to the contractor that did their retrofit work. Who can they contact if they're having issues that's going to be responsive and give them the help they need and set them on their way. As you'll hear tomorrow from talking with Steve Norris from his retrofit, he's like, there's a lot of tweaking and things to the system to get his home working properly. It's basically like finding the optimal seat settings on a new car when you get it. So there's things to keep in mind there. But we need to make sure the homeowner occupant has the right information as they move forward in their retrofit home to understand how it should be working and what can they adjust to make things work better for their habits that may not have been fully accounted for in the commissioning process. So this is one key aspect that we can't forget, and it could hopefully, if we have that proper pass off to the homeowner, it leaves everyone feeling good at the end of the retrofit project. So, and at end of that, we're all done with the retrofit. And again, today, for those who may not have seen it yesterday, this module, a lot of this is based on our guide to deep energy retrofits, and we go a lot more in depth in that guide. So we'll leave this slide up as we get into the Q&A here. All right, so I guess we have just a question from Steve-O. What type of retrofit would be recommended for complex structure shapes? So if the building is not straight walls, but with some bay windows and other projections, it seems that exterior insulation would be challenging in those scenarios. One of the things to look at, so Steve Norris's retrofit will go into tomorrow. He had a bay window, which he actually removed as part of his retrofit as one location, and just made it a flat window. across the wall to simplify things. So that's one thing to look at. My house has a false build out fireplace on the front without anything on the inside for it. When I retrofit my house down the line, I'll be removing that. So one of the things we can look at is simplifying the building in some cases. But it's in that design phase, it's really just planning for it and how is it going to be completed. And that's where it comes into, on that retrofit team, having experienced people that have done retrofits. If you're looking at exterior insulation with a Larson truss or with board insulation, having guys on the team that have done it before, or individuals on the team that have done it before, and they can look at the home and see, oh, this is what needs to be done, or that's what's needed. This is how we can address it. And one of the things with build outs, bump outs and bump ins and stuff on a house, that's where you can get into that practicality of how thick can I reasonably go with insulation. In some cases, you might have 3/4 of your house, or you can go a full 8 or 10 inches depth of insulation, but maybe there's a face that's really complicated, and just to simplify things on that face, you're only doing 4 inches of insulation. So you're still adding some performance, but it's that part of the equation that you work through in the planning stage of the retrofit. And it's how do you address it? And it's getting the team to take the time and have those conversations early on, rather than just have a loose plan. We're going to add 6 inches of insulation. It's going to be great. You order the siding, you order the strapping and insulation, and you go to install it without much of a plan. That's where you can run into issues and delays. Part of the integrated design process is bringing all those people to the table and having those conversations at the beginning. And some homeowners or clients might look at the upfront cost of those initial meetings, and they might be alarmed by them. But in reality, having upfront conversations and planning with the whole project team will significantly reduce delays and extra work and extra costs during the execution of the project.
And I think I would just add to that is the reality is there isn't a one solution that fits all for these projects, where it really comes down to a detailed analysis of the structure of the building itself and what solutions might be best applicable for that. You might want to do exterior insulation, but if there are a lot of complications and a lot of detailing that is going to be needed, well, then either, there might be another solution that need to be sought after. So,
yeah.
So we're at a minute over time. If there's no other questions, we will sign off for today, and hopefully you join us tomorrow for a deeper dive into several case studies that were done in the Calgary area.
Yeah, and I apologize for the issues with the chat. We'll have that turned on for tomorrow, so you can add comments that aren't questions. So, all right, have a great day, everyone.
Thank you.